Hey everybody, thanks for joining today. Today we're going to talk about drift management using Ansible resource modules. Take a look at the slides here. And this slide is similar to one that I used during the last meetup, if anyone had joined that one. But the topic was a little bit different in the sense that I was talking about managing drift control, but I was talking about, I think the last one I was talking more about using Jinja 2 templates to create a configuration file. And then more recently, I put a demo, not a meetup, but just a quick like 8-minute demo of using Netbox as the source of truth in Ansible for the drift control. So today is similar. We're still talking about drift control, but we're talking about using the Ansible resource modules, the network resource modules, and their ability to be able to detect diffs and also to give us insights into what configurations either need to be added or need to be removed so that we can be in compliance with our intended configuration. So we'll talk a little bit more about intended configuration, source of truth, kind of the front end of this conversation. And then I'll talk briefly about why drift is important and how we implement drift. And then we'll kind of like bring it together with some other techniques that typically we can stitch together in workflows using the Ansible automation platform to allow us to establish the source of truth, manage the drift, and use other capabilities like operational state validations like health checks and things like that, and just kind of bring it all together into like a day 2 operational loop. And then we'll switch gears and we'll go into the demo where we'll explore, making changes, using the resource modules, and then, being able to have a subject matter expert acting as the human in the loop to kind of review those changes, those diffs, and just make a decision on whether or not they want to move forward and either merge or override or replace a particular configuration in the network. So having said that, let's go ahead and get started here. So why is it important to apply sources of truth? Well, first, let's just kind of quickly level set to make sure that everybody understands what the source of truth means, or at least in this context of network automation. The source of truth is the intended state of the network, and we can declare that intended state or declare that what that configuration should be up front by either using structured data or the native command line. Today, we're going to use structured data, but you'll see because we're using the Ansible resource modules, they can effectively translate for us between structured data. And what I mean by structured data is data formats that are machine readable, like JSON, and more importantly for Ansible, YAML format. So we'll look at that and the ability to convert them to the native configuration. In this case, we're talking to Cisco routers and also Arista routers. So those need to be in their, their proper, CLI format for like iOS and EOS for those particular devices. Another aspect of source of truth is, it becomes our authoritative reference for the configs of the devices. So configs in routers would be, things like interfaces, the parameters for the routing protocol, network prefixes, SNMP, NTP, logging. Those are the types of configurations that we will create, that intended state. But there's also other aspects of source of truth around the IP address management and creating inventories, or more importantly, creating dynamic inventories from these same types of source of truth. So Ansible is very flexible in the sense that because it can connect with either structured data or through the native command line, we can use effectively really anything that you decide to use up front as your source of truth to ultimately, establish, declare that configuration, and use that to check against later when we start talking about the drifts. So some examples here, this is just, sampling, are things that I've talked about in previous sessions. And one of those is simply creating a backup of a configuration. So if you've manually configured a Cisco router as an example, and you've established like a baseline configuration or golden configuration, if you will, of what that device or that device as it serves in a specific, layer of the infrastructure for, protocol purposes and things like that. If you're building, something like a overlay, underlay and overlay, VXLAN, something like that, you've established that this is a known good configuration. You can simply create a backup for those devices, and that is based off of the native command line, right? Like a backup of the running config or a backup of the startup config. And we can compare against that with the running or startup config on that Cisco router, right? So there we establish, the authoritative reference is the backup files, and any deviations outside of that is the drift. And then we can move forward with policy and then decide what do we want to do. Do we want to accept that change from the device, or merge this two changes together, intended config with that device config, or is it more appropriate to overwrite that configuration? So that's a big piece of it. But the other side of it is, simply building, inventories and things like that as well. So that's why it's important that we can also use structured data, because a lot of the solutions that are currently available, like database types of solutions, like NetBox as an example, is a database of your configurations for the network devices in your infrastructure, but also it can maintain IPAM information. So it becomes a really good source of information for the inventory or the dynamic inventory for the Ansible environment. And other candidates could be like CMDB types of solutions, if the network devices are added into CMDB, like something like a ServiceNow, or it could be something as simple as a spreadsheet. So there's a lot of flexibility because we have so many Ansible collections to talk to these other types of solutions. It's very easy to glean that information or to query, what that configuration state should be. Today, what we're using is a GitLab repository, or I'm sorry, a Git repository, because it's running in my lab infrastructure. And that source controls our configuration files that I've created in YAML. So just kind of like taking a step back to like the Ansible side of things, I mentioned alluded to the inventories. We also, in addition to the inventory where we establish the targets for our automation and create groups and devices and host, there's also group vars and host vars where we establish, configuration files where we can, variabilize those and then use those as part of our playbook. Like as we run through our playbook, we can iterate through these configurations. And the best practice is to store configuration files, in this case in YAML format, in a Git repository so that we can source control manage those changes. So as we iterate through those changes, then they're source controlled in branches in the repository, and then we can use them to build our various environments, like our dev environment, our staging environment, and then ultimately our production environment. So one thing to point out here is that, source of truth is, really the foundational piece of network automation. So, as we're making changes, we're always, working on the front end from the configuration that we declared. And as we need to update that, we try to make it as easy as possible to update, either through APIs being more programmable, like things like the NetBox, or, at a minimum, things like the Git repositories, because we can source control manage those changes for those files. And that's a big, shift or paradigm shift, or in this case, a mental shift for a lot of network engineers, because we're so used to using network documentation where we define what the configuration state is for our infrastructure, and then we go out and deploy it and make changes, as well as, just using things like Visio diagrams and to keep it, more primitive, just, spreadsheets and things like that as well, right? And those are all valid, but they're not programmable and it's not easy to update. And I've been, guilty of this myself by not really updating that documentation, or just taking a long time to update the documentation, or forgetting to remove things after making changes. So this whole paradigm of source of truth just makes that a whole lot easier to manage as we modify our infrastructures using automation. So I kind of spent a lot of time there, but the second part of this is, being able to check the drift. And I thought I had another slide in between, but that's okay. So with the drift, and this is just like a real simple example of drift management, we're really trying to make sure that we maintain a predictable, steady state on these devices, because we don't want those surprises, right? Those Easter eggs of things that we find running in our devices after we make a change. Because in some ways, we're more, exposed, because if we're not able to manage our own, human mistakes, and we're pushing these changes out there, and we're, connecting out of band command line using, secure CRT and PuTTY and, tools like that while we're trying to automate on the front end, there's a chance that we're going to actually overwrite configurations that are valid, right? So someone may have went in as an expert to troubleshoot and had resolved an issue, and then we come along the next time we automate and override that. Or somebody has made a mistake, or just typoed something on those devices that's not in line with our intended configuration, and that's when it would be appropriate, to overwrite those out of band changes. So how we do that, and prevent the mistakes, or at least become aware when we have mistakes, and also from a compliance perspective, ensuring that there's no omissions, that it's not an oversight that we've forgotten to configure some of our security controls on those network devices, and things like that. It's important for us to check for the drift, right? So in this example, I have very simple VLAN configuration. So on the left-hand side, we have the source of truth, and this would represent a YAML, from a structured data perspective, a YAML representation of a configuration. And this is really just a dictionary that's named VLANs. And then we have multiple, VLAN IDs that are listed out. So these are list elements. So when we connect to the actual device, we can see in the running configuration that we have an extra VLAN, VLAN 20, that's not accounted for in our source of truth. So in this example, we actually remove VLAN 20, right? So how are we able to do that? This would be a function of the network resource modules. So if you look at a network resource module, you can kind of think of it as a translator between structured data and the command line, or the native configuration, because sometimes it's not even a command line. The device, like a firewall in many cases, have a REST API, and that native configuration could be like an XML file, or even like with Juniper, it's a netconf file. So that would be XML as well. So what we're able to do with resource modules is work with structured data on the front end so that we can declare a configuration. This example of interfaces is declaring, multiple interfaces on a device, Ethernet, tunnels, loopbacks, and so on, as structured data. And if we were to push this configuration to update the actual router, then we would convert in the resource module to the native format. So back to iOS command line, and it would send serialized data of the command line configuration and push that into the device. But because it's a resource module, it's not the entire configuration of the device, it's a scope configuration. So in this example, it's only interface configurations, because we have an interface resource module. We also have a layer 2 interface resource module that's focused more on like switch port commands and VLANs and trunks and things like that. And then there's a layer 3 interface resource module that's focused on layer 3 interfaces on that device, right, with IP addresses and so on and so forth. So in the reverse direction, if we have an existing device in production or in any of our environments that we want to connect to with Ansible, we would consider that like a brownfield device that's already configured. We can actually glean the configuration or what we call gather facts from that device to bring in the specific network resource module facts, in this case, the interface configuration, we can bring it in from command line and we can parse that into structured data. So pushing the data, we're rendering a CLI config in this case, and then pulling the data, we're actually, parsing that non-structured command line data into structured data. And the modules do this. So this is built into the resource modules. This isn't something that we have to do in our playbook. It's done when we invoke that particular resource module. And this one was for interfaces. The previous one was for VLANs. So kind of tying this all together before we get into the demonstration. So on the front end, and again, I mentioned there's all sorts of candidates for the source of truth. But the idea here is to establish a source of truth. So up front, we're declaring what the configuration should be for the group of devices. So that would be the group variables, and also for the host variables, which would be those specific configurations that apply directly to those devices. And then once we do that, the next step should be is to actually, go out and connect to the device and do a drift check. And how that is established is through using the diff capability and all of the Ansible modules that support that. So if you're using config modules, you can use diffs there, where you look at either the running or startup config and compare that to your source of truth. Network resource modules is basically the same thing. It's just that we're comparing at a more scope level, because each resource module, we would compare each one of those as opposed to the entire configuration. And then we also have the ability to use the validated content that what it does is validated content are roles. So roles are like purpose-built playbooks that Red Hat and the vendors work together in our ecosystem just to make this a bit easier. So instead of having to actually implement this in your own playbooks in roles, then they create a method for you to use validated content that's more prescriptive. But that doesn't prevent you from using the resource modules directly. And actually, in reality, the validated content is using the same modules under the hood. It's just that it's been more curated for you to make it a bit easier. The method for diff checks or drift control is usually predicated around running any of these modules in a playbook using check mode. So check mode will actually connect to the device. And in this case, it'll determine what the configuration would be, and using either the built-in diffs or the diffs that you've enabled, in your playbook for those tasks, then it will show you those differences without making any changes. So normally we run in a check mode so we can see what those diffs are. And then from that, we can review those diffs. So that's where policy comes into play. So with policy, typically we have a human in the loop that reviews, the output of these diffs, and then from that determines which changes should be made and which changes should be overridden, or which changes should be merged with what already exists, and which of these changes should be overridden, because there's configurations on the device that shouldn't be there. So typically we need the human, the expert, to kind of review that, right, and determine, okay, this is a good change. So here's how we're going to apply the configuration. In a workflow, we can establish what we call an approval node. And that's where a person either directly approves it from the automation controller directly to the workflow, or you can use, front end that with our REST API to other things like ServiceNow, or really any of the other, collections that we have with other systems that create like some type of front end catalog, or even a chat tool where you can, have a person that has the correct privileges can have access to that approval, right? So access to the same button that you'll see in our demo to move forward. And when you move forward, that's when you're applying the configurations. So if we're back to like the kind of the most primitive, command line kind of way of this, I mentioned was, just backups of those files. If we needed to overwrite or merge a configuration from that entire file, we're simply just pushing that entire configuration using SCP. So we're either, again, merging it or overriding. The resource modules are more scope. So we're just, working with one type of protocol or one feature at a time that maps to a resource module. And then Jinja 2 templates give us the ability to round out the resource modules, because if we have a resource module that doesn't support a very specific configuration, we can always, write that as a very scoped Jinja 2 template, and then compare that with, a show command with a filter directly to that configuration in the device, and then do a comparison that way. You can also use a Jinja 2 template to create the entire configuration, and then have that as the intended config that you compare against the running or the startup config in the devices. So the idea here is to apply the configuration and then ultimately test and validate that change. And that's where, we have assertions to do things like show commands, and then through parsers and filters, we can evaluate the response that comes back for pass-fail criteria. So a lot of times it's like up or down, or something's missing, like a network prefix is missing from a routing table, timers, those types of things. And to make that easier, we have validated content around health checks now for some of the main protocols like BGP, OSPF, VPNs, interfaces, those types of things to validate. So that's kind of like bringing it all together. What we're going to double click on here in the demo is more around the resource modules, and comparing that to our source of truth, which in this case is going to be the Git repository and some YAML files. And we'll see that in action in a workflow where a human is in the loop and can review and make a decision on what to do to move forward with those files or not.